Thank you so much for everyone for joining. It's a great pleasure to be able to talk about the evolution of C Sharp. The best time to ask questions or make comments is anytime you have a question or a comment. So please don't hesitate to post your questions or comments on the chat. I'm going to keep an eye on the chat along the way, and I'll answer your questions or respond to your comments as soon as you post them. So let's get started. I want to talk about the C Sharp 11, which is the most recent version of C Sharp as of today. And I want to talk about some of the amazing things that are in this particular language. I'm going to be doing some live coding, show some examples along the way. And of course, if you have a question or a comment, I'll be delighted to hear them and answer them as well. Well, C Sharp 11, and especially the language C Sharp itself, I started using C Sharp way back when C Sharp was introduced. I'm obviously dating myself, but I've been programming for about 35 years, give or take. And when C Sharp was introduced back in time, I'll admit, before the time of C Sharp, I was programming in VB, and then of course VB, .NET, and languages like that along the way. And back in time, programming ASP before ASP.NET came about. So it's been really fun experience watching the evolution of C Sharp. It's a language that has had some interesting features that did not exist in other languages back in time. But of course, that pace of evolution has been much more rapid in years after that. There are many enhancements over the years in C Sharp, as we know. But one of the interesting aspects of C Sharp is it really has streamlined the use of the language from the programmer point of view. As a programmer, I program in about 15 different languages. And what I mean by that is I'm not good in any one of them, but I really, really like programming languages. And oftentimes when I'm programming in a certain language, I would ask the question, can I use the feature that I know exists in another language? Is something like that exist in the language I'm programming in? Or can I bring in some of those interesting features into it? Part of the reason is it's convenience for me as a programmer, but more important for me at least is I really, really like concise code. I want to set apart difference between what I would like to call as a concise code and a terse code. A terse code and concise code are really short, but a terse code is waiting to hurt you. A concise code is actually easy to understand, but easy to maintain as well. As an example, almost always when I'm programming a series of if and else statements or expressions, I would often ask the question, is there a better way to really write this? Is there a more concise way to write it? And I have to admit, I really was excited, and I am excited, when I see pattern matching become a commonplace in many languages, including C Sharp. But of course, by writing concise code, we can write code that is less error prone, but also easier to understand, easier to maintain, less time and effort as well. Who wants to spend a lot of time trying to understand the code? We want to really be able to be very communicative. Well, let's talk about the most recent changes in C Sharp. And I'm going to cover some of the most important aspects in C Sharp and dive into some of the behaviors and variations as well as we go along. Let me start by talking about raw strings. Raw strings are a feature I've used in other languages for quite a while. I've used a feature called here docs in other languages, and here docs are ability for you to write a little text, if you will, free flowing text anywhere in the code you want to. But I do have to admit one thing. When I've used here docs in a few other languages, as much as I like that feature, I get a bit angry and annoyed when the feature doesn't work so smoothly at certain times. What I really like about here docs is it's very hygienic in terms of how they have done it. Let's take a look at it. So I want to start by looking at a multi-line string for a raw string. A raw string is a feature I've used in other languages, and they're often mentioned as what are called here docs. And I have to admit, I really like here docs, but I get really annoyed when there are times when it doesn't work really well. I have to say that the concept of raw string in C sharp is very nicely streamlined and very hygienic, if I should say it. So you write a here doc or a raw string or a multi-line string using multiple double quotes, at least three. We'll come to that at least three part a little bit later. So let's dive in and look at an example. So I wanted to start with a little function called the greet. And the reason I want to write it as a function is it's a great way to take a look at the power of indentation in the raw strings. So let's go ahead and print out right in here. Let's go ahead and print out the result of greet. But I want to see the effect of indentation as well. So let's go ahead and output right here, maybe a few dashes here, so we can compare the output of greet with those dashes, if you will, in here as well. So let's take baby steps and work our way through it. So what do I want to do in here? Well, I want to return a string. So let's start with the message is equal to, let's start with a little hello. We'll expand on that a little bit later. So here is a message I want to output on the screen from this particular function. So you can see the output of hello with the dashes above and dashes below. But I want to really write a multi-line string. So how am I going to do this? So what I want to do here is to start with three double quotes, as you can see in here. And within this, let's go ahead and say, hello there. And I'm going to say, let's say, thank you so much for joining. Great to have you here. So that's a multi-line string that I've created right in there. So you can see every line of the text being printed. You have hello there. Thanks so much for joining. Great to have you here. And right there is a multi-line string. So that's the first thing is you started with three double quotes and then you put that text in there. But what's really cool about this is you can have multiple quotes in the raw string. So let's say, for an example, the following is let's say three quotes, and I'm going to simply put three quotes right in there. And the designers of this feature realized that they cannot predict what you want to have in a string. So what if I really do want to have three double quotes in a string? This obviously will not work, and it's going to give us an error, as you can see right there. Error, it says a string literal delimited must be of its own in its own line. Well, it is thinking that you're ending the quote. So how do you accommodate that? So that is the reason why they said at least three double quotes. So I'm going to put four double quotes now in here and execute the code. And you can see that it's pretty happy to put the three double quotes in there for us. So you can have these kinds of strings in the content if you want to. So also, if you really want to put other things, for example, for instance, I can say, she said, and I'm going to put a double quote in here, and it's a great day. So you can see I'm able to put a double quote in there, and a single quote in there as well. Not a problem. You can embed these without having to escape. So that's pretty darn good. So you can put single quotes and double quotes in there as well. But what about indentations within that particular raw string? Let's get back to the text we had a minute ago. And when I run this, notice what the compiler smartly did. This is what I really like about hygienic syntax is you are not putting the effort. The compiler puts in the effort to make it work like the way you would like it to work as a programmer. So as a programmer, when I'm writing a function, I want to indent my code within that function. So potentially, for example, I might even push this into two spaces like so. But when I run it, notice there is no indentation at all in the string we created. The H and the T and the G all line up to the leftmost column, as you can see, right under and above those dashes. But on the other hand, if I take the thanks and move it a little bit right there and run the code, notice that that line is indented, but not the other lines. So what the compiler realizes is that this indentation that you see here up to this point is really not an intended intended indentation. But how does it know how many indentations to actually remove? And that information is based on this very last line. So all the indentation before the double quote are removed. So this part goes away, and what is after that is actually preserved. And that's why H is starting at the leftmost column, but the T is intended in the thank you, as you can see. But on the other hand, because it's using the last line to check on the indentation, you're not allowed to breach that indentation in your text. So as much as this is working, as you can see, if I were to remove this indentation where the T is going to the left of where the double quote is ending, notice we get an error at this point saying the line does not start with the same white space as the closing line of the raw string, and that was not permitted here in this particular case. So that is basically the idea here, is that the indentation is well implemented to be very sensible for us as programmers. So you're not fighting the syntax. You naturally write code and you are able to move on without having to waste your time. It's less error prone, less tedious, easier to write, easier to read, easier to maintain as well. And I have really good respect when that happens. Not only can you write raw strings, you can mix raw strings with another feature, which is the string interpolation as well. So let's take a look at an example of how we can use string interpolation in here, and where we can take that even further. So let's take a little example and play with it right in here to see how this actually works. So let's start with, let's say, a name is equal to, let's say, in this case, how about this? Let's start with a greet is equal to hello. And let's also start with who is equal to world right here, like so. So let's start with a little example of a string interpolation, if you will. So well, first of all, let's step back to the world of write line. When C# was introduced, day one, they had an ability to substitute values into a string. It worked for a long time, but it was still a little bit verbose, a little bit tedious. Honestly, I was not complaining a whole lot because that was still much better than what other languages didn't have back in time. But here's something you could have been doing from day one in C sharp, and that is you can put a curly zero right here, a comma and a curly one, for example. Then you can say greet and who, like so. And as you can see in this case, it prints hello world. And even though this worked for a long time, this is still a little bit verbose. C sharp wants to make things concise for us, so it's easier for us to write code. We don't have to waste our time and effort writing things. So in here, as you can see, I want to start with a little dollar and a double quote like so. And within this, I can simply drop the variable or a expression of, it could be a function call, could be a variable, any piece of code you want to evaluate, you can put within those curlies. So you can say greet, comma, and a who, and definitely that is a lot easier to write. But it's not only easier to write it, it's easier for us to make changes as well. Imagine the top line for a minute. Both of those lines actually produce the same result, but in the top line, if you want to insert something between greet and who, you may have to go back and renumber them. Not so here. You simply drop what you want in the middle and off you go. That's less effort, and that is the way it should be, where you don't do mundane things, you do things that are easier to express and you move on. So this is done really well in terms of the string expression, as you can see in here. So that's exactly what we are seeing in this case, is the nice, beautiful string expression, interpolation of the string. You're able to see it. But not only can you do interpolation already, you can mix that with a multi-line string as well. So for example, in here, you can go back to this code and you can add, if you will, those three double quotes quotes, as you can see right there. And then you can come down here and put those 3 double quotes like so. So you could write them in a raw string as well, as you can see in this particular case. So we saw the string interpolation working with raw string, but you can also insert a few other things. For example, what if you really wanted to print the greeting message, but I want to put a greet right here. But as you can see in this case, it says, hello, hello world. But I want to put the hello, the second one, within a curly brace for whatever reason. This could be a text where you want to represent things within a curly braces. Maybe you want to show them as properties. Maybe you're writing a code that is explaining how to create a particular syntax. So in this particular case, when you run the code, what are we going to see? That was an error. It says the interpolation of raw literal does not start with enough dollar characters to allow for this many consecutive opening braces, it says. So you can put 2 double dollars like so. What you're telling the compiler is that when it sees the dollar, the curly braces, you're going to have a certain curly braces to represent the data and certain curly braces to represent the output. So in this particular case, as you can see, if you really want to, you can put 2 curly braces like so. And again, you can put 2 curly braces right here as well. But then when you run the code, you can see it actually says hello, but a curly greet and a word. So what you're telling the compiler is that 2 curly braces should be used for expanding the expressions, but a single curly brace should be kept intact. This again avoids the drudgery and verbosity of escaping through the code. You convey the intent more clearly, saying, hey, expressions are embedded within 2 curly braces, and anywhere you see different curly braces than 2, treat them differently. So if I were to put 3 curly braces right here and run the code, let's see what it actually tells us. Notice in this particular case, it took the 2 curly braces as evaluation of the expression, and the outside one as the curly. That's why you saw the expansion of the hello right in there. So this is a feature where you use any number of dollar symbols to convey the number of curly braces that embed the expressions in your code. Well, not only that, one additional feature I want to talk about here is a multi-line string interpolation. Now, you may wonder, why in the world would we want a multi-line string interpolation? What is the purpose of that? So going back to this code right here, notice it says, hello world, but I want to say one more thing in here. Maybe I want to greet the person with, greetings of the time of the day. We are all online here. Some of you probably are in early morning hours, some of you mid-afternoon, some of you maybe evenings or even late in the night. So what if we can greet people based on the time of the day? So in this case, I'm going to say when is equal to, let's say, 0700 for a minute. And then what I can do here is I can put a little curly brace, and notice now we have an expression that we are going to embed within this particular raw string, but our expression, rather than being a variable or even a short function call or an expression that can fit in one line, we want to write a multi-line expression. In other words, within a raw string, you want to write a full-fledged C# code. Now, you can argue, is that a good idea? Personally, I would say I would not want to put a lot of code within raw string. However, I'm a big fan of one mantra that I follow all the time, and that is make it work, make it better real soon. So I'm a big fan of this, make it work, make it better real soon. So if you ask me what is programming, here is my opinion of what programming is. Programming is a series of mini, you could say, experiments where we transform a series of, I would say, unknowns into a series of knowns. So in other words, this idea of experimentation is extremely important in our field. So as I'm writing code, don't ask me to create functions and put stuff in a function and call it, because honestly, I don't even know what I'm trying to write at this point. There's a lot of unknown. So I want this ability to quickly experiment. So will I leave full code within a raw text in production? The chances are maybe not. But will I do it when I'm writing code? Absolutely, because I want to try something, experiment, play with it, and then decide to refactor it when I have a better understanding of what I'm actually writing. So for that reason, I can go back into this expression like so, and you can say when switch, and I can use a pattern matching syntax right in there. And just as an example, let's just go ahead and say, greeting, hello, a word, and we can say, good, and we can put something after the good. So what do we want to say? I'll go ahead and say night here for a minute. So I want to start with a hello world, good night as the very first thing. Now with this underscore, I call the underscore as the international symbol of I don't care. So that is my definition of what the underscore is. This is called the discard symbol, but I'd like to call it as the international symbol, if you will, of I don't care. So I don't care about that particular value or data, whatever it is, just give me a night. But on the other hand, I could say if it is less than, oh, let's pick a number. Let's say it's less than 8 p.m. So 8 plus, 12, we could say is 20 hours. And you could say if it is less than 2000, what do I want to do? 20 hours, I'm going to say maybe evening. So on the other hand, well, obviously in this case, I need to put a little comma in there to put the switch, and you can see that it says good evening. On the other hand, if it is were to be, oh, let's say it's less than, oh, let's pick a 5 p.m. if you will. So at 1700 hours, we could say it's afternoon, maybe. And then finally, we could say if it is less than 1200 hours, we could say morning, if you will. So essentially, we can write code right in there to deal with a pattern matching. Again, like I emphasized, would I be comfortable leaving such a code in production? The chances are not, because to me, it doesn't convey the intent very quickly. But this is great for experimentation. And as we evolve the code, this doesn't ask me to get involved in ceremonious process and instead focus on just getting something to work, and then have the wisdom to refactor it to make it easier to understand, to make it readable as well. So that is basically our discussion about raw strings. One last thing to mention about raw strings is this is purely a compiler feature. So these are transformed into strings at the time of compilation. So you don't have any overhead at runtime, but you got the flexibility at compile time to write the code in a nice way. That's basically what you're seeing with this feature of raw string. Really a good time to ask question or make comments is anytime you have a question or a comment. You can ask questions if you have any questions. If you like a feature in C Sharp, you can definitely comment on that as well. You can say that your favorite feature or you like it. Or if you don't, that's a perfectly good comment as well. If I was speaking in person, your facial expressions are going to be the feedback. Right now, I have zero feedback. So that's one of the reasons I keep encouraging. So post your comments and give your feedback. If you like a feature, that's good to know. Oftentimes, when I give a talk in person, somebody would give me a thumbs up to say they really like that feature, or they would kind of do this to say they're not still sure if that's something they like or not. So typically, a multi-string interpolation would kind of receive that, right? I don't know if it's a feature or a flaw that I can do this, and then you can tilt over to, yeah, that's great to experiment. So that's something to do. Yep, absolutely. And if you have a question, please post them. You can also unmute and speak. I'm assuming that's possible. If you're able to unmute and speak, that's great as well. Andy says, really like it, ideal for sounding out ideas, bingo, and getting the ideas of output can see it used immediately. Absolutely, that's what I like about this. But of course, you have the wisdom to refactor it so it's still easier to maintain as well. Baker says, what is the performance storage impact of all the convenience of interpolation strings? That is, what does the IL look like? Beautiful question. And my recommendation is compile the code, open it, and take a view at the IL. And what you're going to see is that at the end of the day, it is still a string. It doesn't cost anything at the IL level. So that is the beauty of this, is you have no impact on performance because it's as good as you and I writing a much verbose string. But the beauty of the convenience is the compiler takes on all of these things. So I would recommend that you compile the code, generate the IL, and take a look at this using a IL viewer and see what it shows for you. That's a good way to analyze that as well, and see what the impact is. And you'd be pleasantly surprised that there is no real impact under the hood. So we talked about this beautiful idea of raw string, but I want to mention one other feature that can be reasonably useful from the point of view of encapsulation. There are times when you create a class that is intended for your use, not for anyone else's use. When I say anyone else, even within your team, you don't intend for other people to use it. So yes, you can do public and private and so on in terms of protection, but there are times when you truly want simply that, a file level, meaning what you define is visible within a file, but it's not visible outside of a file. Now, of course, the question is, why would we want something like that? Is a reasonable question. And the answer to that question is, you are creating maybe a data structure that you want to use within a particular class, but this is not for intended for others to use. Let's take a look at an example of this just to entertain this thought. So I'm going to create a little file here. Let's go ahead and call this file as util.cs, if you will. So here is my util.cs. And within this, I'm going to say a public, let's say a class. And oh, let's actually start with a namespace. And I'm going to start with this example namespace. But within this, I'm going to say public class util as a class I want to create within this particular file. So as you can see, the util is a public class, but then I'm going to say over here a public string, let's say a compute function I want to call. But within the compute function, let's say return node dot to string, I want to call it. But what in the world is a node? So I could simply say here, I want to create a variable. Let's call it node is equal to new node, and I create a node instance. But what is a node? If I were to create a node as a public class, anyone can use it. I could try to keep it internal to my assembly if I wanted to. But in this particular case, nobody has business using it. Maybe I'm experimenting. Maybe this is purely for my internal use. I don't want anyone ever to be using this. So for that reason, what I can do here is I can say not a public, but a file class, let's say in this case, node. And this particular node is purely internal to this particular file. So I can say override, and I'm going to create the toString function right here. And the toString function is going to simply return, oh, let's just return a test here, if you will. So in this particular case, what I have is a file, a local scoped object, rather a class called node, which I'm using within util, but that node is not visible outside of this class. So to understand this further, let's go to program.cs right here and take a look at this file right like so. So what I want to do in this particular file here is I want to create an object of the util and I want to use it. So we can say a console write line, and let's say new util dot compute, and I can call the compute method like so. So if I were to go back and run this particular code, what do we notice in here? Well, it says test, so the code executed. So I can say a util equal to new util. I can create an object of the util we wrote. But what if I say var node is equal to new node? Notice the node doesn't appear anywhere here. And the reason is it's a file local scope. I cannot see it outside of that file. I cannot use it elsewhere. So that's basically what you're noticing in here, is that idea of really keeping that to the local to the file, and we don't really want that to be exposed anywhere else. So, and here's another benefit. The benefit is you can almost, have not have to worry about collision of names. Even if you have another class anywhere else in your application with the same name as a file local scope, it will not collide with it. So you could actually have multiple files with the same name of the class. In other words, the name is resolved based on the file, so there's no collision at that particular point, if you will. And maybe that's a way to think about it, if you will. So if I go back to the program.cs in here, and if I were to, let's actually go to the util, if you will, and where we are outputting it. What if I were to simply, use the output to convey the node itself I want to output when that function is being called, like so. So if I were to go back and run the code right in here, let's see what the output is going to be in the console. It is actually saying test. Let's go ahead and do one more thing. Let's go ahead and get rid of the toString method, and we'll simply return the result of that function. Obviously in here, we'll simply say return the string on it. Actually, let me just go back here and output and see what it were to output, and if to see if it gives us a glimpse of the details, if you will, and see what the output tells us. Notice here it says example.util, and then the node right there. It's a very mangled name, as you can see in there, and that's why there's no chance of collision, if you will, if you have other classes with the same name in your application as well. You don't have to worry about it. So again, it's an interesting feature. Will I use it extensively? Not really. But will I have purpose for it occasionally? I think so. Going a little further with this, one of the concerns with using structs is you want to be able to have data members of a struct. But what if I don't initialize a data member of a struct? So the beauty in C#11 is that can be initialized automatically for you, so you don't have to put extra effort to initialize if you don't want to. Let's take a look at an example of that, just to appreciate what that means and how that looks like. So let's go ahead and take a look at an example of that. So in this particular case, it's an auto initialization I want to show. So let's start our way and work backwards from here. So I want to create an address, let's say, and I have an address 1 and address 2 I want to create and display them. But I want to create the addresses in one of two different ways. So I can say address 1 is equal to new address, which we're going to create in a minute. I'm going to say a street number. Let's say a street name as well I want to provide in here. So the street name, let's go ahead and say, is a main street, like so. Oh, let's pick a city here. Let's say New York, where I was last week, and an amazing city. So we'll say here's a New York. Well, that's one way to create it. But what if I were to create an address 2 in this case, but I am not going to provide any of those details, like so. But I want to add in here, maybe a street is equal to, and what do I want the street to be? Let's give an uppercase street, and maybe I'll say in this case, this is going to be a Smith Street, let's say, like so. So we created two different objects of this struct I'm going to define, where, pardon me, the struct, I can provide the number, the street name, and the city, pardon me. And the second one, I decide to provide only the street in this particular case. But what happens to the fields or properties that were not initialized? That's a question. So let's go ahead and create a struct called address like so. And within the struct, I want to define these, excuse me, properties. So I have a public, let's say, address constructor, and here we'll take a number as an argument. I want to also specify a string, let's say a city, and a string which is going to be a street and a street name, if you will, and a string, let's say a city, like so. But what do I want to do within this? Well, how about saying we have a number and we have a street, if you will, and a city, and all of those we're going to assign based on a number, a street, and a city as well. So we can initialize those three properties directly in here. But what are the properties? Let's go ahead and say a public, let's say number. And in this case, I want to provide a get, but I want to make it read only. So I only have an init, not a set. So I can initialize the number, but I cannot change it after I create the object. Similarly, I want to say a string, and we'll make this a street like so, and a get and an init again. And finally, we have a city here as well. So when I run the code like so, what you notice here, maybe a good idea to provide an override, let's say in this case, a string, a to string. And what do I want to do within this? Hey, we can use some of the things we saw earlier. So we can provide over here maybe a number, if you will, and maybe a street like so, and then maybe a city as well. And we can provide nicely the code for the toString method here as well. So notice in the case where we specified all the data, we see 10 Main Street, New York. But in the case where we did not specify all the data, it took the street we provided. So you see the Smith Street, but what about the number? That received the default value, which is 0 for the integer. And what about the city? It got an empty string as a default as well. So that is really saving us the effort by initializing to the default. So that is the auto default of the structure. Now, it's great to provide automatic default, but an opposite problem, what if you want to insist that some data is actually provided? So the language gives you the flexibility to go across that pendulum. You can swing all the way and say I want a default, or you can swing all the way and say I really want you to give me a data. I want to make it a required data. You can do that as well. So in this particular case, I want to convey that something is required. But why do we want to do that? Let's discuss that before we come up with a little example to think about it. So in here, when you define a class, oftentimes in the traditional way, what did we do? We would define a class, we would define the members of the class, we would then painstakingly write a constructor for that as well. And then, of course, by the time we are done with all of that, we would have duplicated so much code in general. Let's look at an example to understand what that really means here. So let's start with the pet.cs file like so. And let's say namespace again. Let's go ahead and say this is going to be an example namespace like so. But what I want to do here is to create a class called a pet. Now the pet is going to have a couple of things. Let's provide a public string. Let's say this is going to have a name as a property. So I'm going to say there's a get and there is a init as well. I don't want to change the name of a pet after you create it, but you can initialize it. But when somebody is trying to create an object of this pet, how do you convey that the name is actually required? You could write a constructor for this, and you could say pet, and you could provide a name over here like so, and you can say name is equal to name, and you can initialize it. But in this case, notice we took the effort to write a constructor, but you may potentially have a public, let's say in this case, an age, which could also be initialized, and you can get the value as well. But I'm not keen on having an age given to me. Age is optional, let's say. So you didn't take the age as an argument in the constructor like so. So now we could write a public, let's say, override. And in this case, you could say a toString, let's say string toString. And what do I want to return from the toString? Oh, let's go ahead and return the name that we have and maybe the age of the pet as well, or the values I want to return. Let's start with this code for a minute. So how do we go about using this particular class that we just wrote? So you can go to the program and you can create an object of this particular class if you really want to. You could say, for example, in here, oh, let's go ahead and say a buddy is equal to new buddy, but you can give a name as an argument in this particular case, right? New pet rather, and you can give a name as buddy like so. But I don't care to provide an age right now, and I want to output the buddy, let's say, in this particular case. So what is going to be the output of this particular call? So let's go ahead and run this code and take a look at the output it produces. Now, this was a little bit of an effort here. You can see the output is buddy, and the value is 0 for the age because it's not initialized, but that's quite a bit of work. What is your intent though? Your intention here is to say that name is required, don't create without the name. So if I go back here and don't provide the name like so, notice we got a compilation error saying, hey, you cannot create a pet without a name. That's not allowed. That is our intent. That's what we want to achieve, but we want to do so in a concise way with a lot less code as well. So how can we do that? So going back here, what you can do is simply add one more keyword to this. That's it, just one keyword. All you do is you say public and you say required name, which is a string type as such. So you said public required string name, and you are emphasizing that field is required. Here comes the bonus. Now you can get rid of your constructor like so. So we don't have a constructor right now, but if I go back to the program.cs, notice I still get that compilation error. Now, without the required, let's just remove that for just 1 second. If I go back over here, notice there's no compilation error. But if I go back here and add the required and go back to this code, you can see a compilation error sitting right there because the name must be set in the object initializer or the attribute constructor. So now I can say name is equal to buddy. And as you can see, the error went away and it's not complaining anymore. So this removes, for one, the effort we have to put in. You didn't have to write that constructor if you don't want to. So that's basically conveying the intent that a field or a property is required. And of course, it removes the duplication of code and the burden of initializing in each of the constructors. If you're going to have multiple constructors, what's going to happen? That is even worse in this case, because in each of the constructors, you got to initialize the name. You don't have to do that right now. You're letting the user provide it without needing to write multiple initialization in different constructors. You can also avoid accidental assignment of a default value. You're like, oh my gosh, the name is empty. How sad to have a pet with no name. No, you're not going to run into that issue. It's going to insist on it. But almost any feature has consequences. So what is the consequence of this? Suppose we were to, let's say, write a constructor right now. So given this, all the things are working fine, as you can see, but I go back here, but I want to add a constructor to this class. So I say a public, let's say, in this case, a pet, and I want to take a name, but I also want to take an integer age as well. And so I'm going to say that I have a name and comma, let's say in this case, age is equal to, let's take the name and age and initialize it. So a good intent, right? You want to be able to provide a name and you want to be able to provide an age as well. So now what's going to happen? You go back to this code right here. You want to provide a name, which is a buddy, like so. So you say buddy, and maybe buddy is 2 years old, and you provide that. But did you notice the compiler is complaining still, which is sad, isn't it? Because when you look at the compiler, it says name must be initialized. Well, the compiler doesn't know what those arguments you passed, parameters you passed to the constructor. It doesn't know you already initialized the name. So sadly, you're going to say name equal to buddy, and you're going to initialize that, which really is absurd, isn't it? So what can we do to get around that limitation? What you can do here is you can go back to the pet and you can tell the compiler, hey, compiler, let me tell you what I'm doing here. And you provide an attribute like so. So the attribute that you want to provide in here is called the set required members attribute. So back here, you can provide the set required members attribute. So what does a set required members attribute actually do for you? This is telling the compiler, hey compiler, I want you to know that I have taken the effort to initialize the required attributes, so we don't have to insist on that being provided. So going back to this, I can then bring in, as you would expect in here, the set required member attribute. And of course, without it, this code would not compile. It's going to require that attribute to be provided. But with that set required members attribute, you don't have to specify the data in here. The compiler is going to be just happy without it in this particular case. That's the benefit you're going to get out of this particular approach, is that you don't have to redundantly specify that. So let's make this work right here. So I'm going to go back here and say using, and let's bring in the system diagnostics right here, and dot code analysis, and that brings that attribute over. But when you go here now, you can see the compiler error went away, and you can simply initialize it. Good news and bad news, right? With almost any of these features, what are the consequences? The good news is you're not burdening the user of the code. But the bad news is you still have to be careful about it. If you don't actually initialize the name, but you lied about it, right? Well, okay, we're not going to lie about it. Maybe by mistake, we didn't actually initialize it. Maybe we added another field later on, but our constructor is not initializing it. What's going to happen? Well, unfortunately, in this particular case, the limitation is the compiler assumes you have done the right thing. So when you run the code, you can see the name is actually empty. So in other words, you need to do proper unit testing of the code, maybe a good code review, and make sure when you use the set required members attribute, you really are setting the attributes. That is something you need to be really careful about and verify when it becomes very convenient. So that's one of the limitations of this approach as well that we have to be careful about. So we are making good progress over here. We started out by talking about the raw strings feature, and we talked about very many different things you can do with it. Like I said, that's a feature I've used in other languages for a long time. Really something I enjoy quite a bit, but I see it very hygienic here in C#, so I have the respect for that reason. We talked about the file local type. Not that I would make great use of it, but nevertheless, it's a useful feature to have. We looked at auto default structs, and we looked at the required members. We still have grounds to cover quite a bit. 3 more exciting features, and one that looks a little confusing, but we can try to understand what the intent is. So let's get down and talk about 3 other features. I'll spend a little bit more time on pattern matching and a lot less time on the other 2, but let's take a look at those as well before we go on with this. One question over here is, yes, C#11 supports OP, dynamic, functional, and has a lot of features, but how does it compare with Go, Scala, Python, etc.? I suspect heroes of horses for courses and what you know. So I do have to say that what I like about C Sharp is that the language has evolved really well over time. If you want to use the word, it has aged well. I would say absolutely it has. And that's a really good question, Dick. Thanks for asking that question. And if you look back in time, about maybe 30 years ago, languages did not live that long. Somebody may argue, my gosh, COBOL is still being used. Oh yeah, assembly is still being used, and COBOL is being used in various other languages. But languages don't stay popular for more than 10 years. But a few languages have completely defied that trend, and they have stayed longer in terms of duration. Look at Java, which has lasted for 8 years. C Sharp has lasted for a good 23, give or take, years. JavaScript, kind of scary, right? Has lasted almost that long as well, and so are other languages. And that's a merit to C Sharp, and it compares really well with a lot of other languages. Languages like Scala and Kotlin have taken a lot of ideas from languages like C Sharp, with all respect. And I think that's a healthy thing. And that's an evidence to know that C Sharp is doing well. I do have to say that C Sharp is way ahead of game in certain areas. When you look at the support for records, their support for pattern matching, their support for raw string, these are the things available in other languages. There are certain things. One of the very first books I ever wrote was a book on .NET Gotchas. And .NET Gotchas basically talked about some of the problems in .NET. So some of them are going to be fundamental. That's legacy. You cannot throw them away. But the language has evolved considerably well to stay competitive, to stay relevant to the field we are in. And it says there seems to be a much hype and enthusiasm for AI, but there are any tweaks expected for C Sharp, not specific to those that I know of. And if there are, I would say, with enough insight into it, I would say those are very unlikely to be language features. I would say the evolution of those would be in library features more than language features. I cannot think of why the language would evolve based on AI and things like that. I can see substantial, changes coming through based on libraries, but not as languages, I would say. Very good discussion on that one. Let's talk about a couple of more things in here. I want to mention about one other feature, which is Nameof, which really reminds me of a feature in Ruby where they had a symbol. And I have to say, I'm happy to see that in C Sharp after all these years. And they've made a small extension to that in C Sharp 11, where you can use Nameof in attributes as well. So if you're creating an attribute, you can use the name of a particular field or a method by saying Nameof and the name of the method in an attribute. Is it a very compelling feature? Personally, I don't feel that way, but it's nice to have that ability. Do I use symbols when I program in Ruby? I do, but not too often though. And I've not had that opportunity to use in other languages, but I would make use of that in C Sharp now that it's available. But you can also use that on attributes if you're interested. You can definitely take a look at that as well. Now, a bit of a confusing idea here. We all know what abstract means. We all know what virtual means as well. And virtual method can be overridden. Abstract method has to be overridden. One word you would never associate with abstract or virtual is the word static. It makes no sense for a method to be static and virtual. Well, it makes no sense unless we define the meaning of what that really means. So keep in mind, when you define a function as a virtual function, that is dispatched accordingly at runtime. We call it dynamic binding or late binding or runtime binding. That concept still exists. You would write virtual methods, instance virtual methods, and instance abstract method in classes. But if you want to insist that a class implementing an interface provide a static method, how do you emphasize that? This is where static abstract comes in. The word abstract is to emphasize you provide an implementation, not for any runtime capability. This is purely a compiler feature. So what's the purpose? The purpose, let me put it bluntly, you're writing an interface, you're going to have classes that implement the interface. You want to emphasize that the class implementing an interface provide a static method. That's all it is. You're going to emphasize that class implementing an interface provides a static method. How do you emphasize that? The short answer, we couldn't do this before. You may get an error at some time when you're using a particular class in a context. But that compilation error comes from the user of a code, not when the compiler compiles the code, the class itself. This shifts the burden of that compilation error from the user of a class to the author of the class. That's the benefit. So in other words, it's a fail fast, if you will. You as a person writing a class gets this error as soon as you write your class. That's the benefit of this. Let's understand this with a little example and see how this can be useful. This is useful to create generic interfaces, meaning interfaces that use parametric type or generic type, but you want to implement some algorithms. This is going to require at least one parametric type to support it. Mainly, you're going to see this during operator overloading. Well, an example would help us to understand this better. So let's start with an example here. So I want to create a public interface, and the interface I want to create right here is going to be called as I compare. You know, a comparable interface exists, nothing to do with that comparable interface. I'm just cooking up my own interface right here, where the type parametric type P, I would say, implements the I compare of P. So within this, I want to implement a function to make comparisons. So I say static abstract. So what does the static abstract really mean? You are saying any class that implements the ICompare interface is required to provide a static method which conforms to the signature and name that we specify here. So in this case, I'm going to say bool operator less than or equal to, and p, let's say first, and p, let's say second, and I want to provide that function. Similarly, I want to provide a greater than or equal to. That is all this interface is emphasizing. So this interface says any implementor of the ICompare is required to provide a static method operator less than or equal to and operator greater than or equal to. What if I don't? Let's find out in a minute. So I'm going to create a pet buddy is equal to new pet. And this is going to take a name, if you will, is equal to buddy. And let's say age is equal to, oh, let's say a value of 5. Similarly, I'm going to create one more pet. We'll call it rover. And the rover pet, of course, is going to have an age, oh, let's say a little 2 years old. So we got two of these classes we are creating, instances of this class that we are creating. But what do I want to do after I create this? I want to say right in here, after we create it, I'm going to say buddy less than or equal to rover, or that rover or our buddy is greater than or equal to rover. So I want to define the less than and greater than on that pet. Well, time for us to implement this logic. But notice how you are relying on a less than or equal to and a greater than or equal to be available. But what if you don't provide it? You want the compiler to tell you that's needed, that it needs to be provided. But I want to get that error even before we get to these points. That's the whole idea, isn't it? You don't want to wait until the usage to get certain errors. So what are we going to do? I'm going to go back here and say public, let's say a class called pet, where the pet inherits from compare of pet, as you can see. So we wrote this class like so, and I'm going to say public string name, and I want to be able to get the name or to initialize it in the start. And similarly, let's provide a age as well, which you can also get and initialize if you will. But then I'm going to go ahead and simply make use of this. So let's go ahead and say public. Let's go ahead and say in this case, and I don't even need any more function. That's all I'm writing so far is to create the pet. What is the error? Did you notice even before we use the class as an author of a class, I got two errors. That's the power of this particular feature. It says pet does not implement interface member operator less than or equal to and operator greater than or equal to. So the emphasis here is the compiler will tell you you need to have static methods. So if I go back to this code and if I say public bool and I'm going to say operator less than or equal to, and I say pet first and pet second. So what am I going to do here? Simply, I'm going to go ahead and return, if you will, in this code. And what do I want to return? I'm going to simply return first dot age is less than or equal to the second dot age. That's what I want to return. Similarly, I provide a greater than or equal to, and I say is greater than or equal to age. So we wrote those two functions. Now, when I compile the code, you still get an error. What's the problem? I did not define them as a static method, right? So that's what the compiler is telling me. You need to, implement a static method. Now the error is gone. So in short, what does static abstract really mean? I want you to think about the word abstract. Abstract requires a derived class to implement that method. A static abstract requires a derived class to implement that static method. That's it, right? That's the easiest way to remember it. Otherwise, we are looking at this and like, oh my gosh, what does it mean to have a static method? Is it polymorphic? No. Static methods are never polymorphic. It has no impact at runtime. The runtime doesn't deal with it, period. It's for the compiler to verify that you are implementing the static method. So now when I go back and create a pet and I ask it to compare, we can get the results of this, as you can see in here. But the emphasis is that we implement a static method that is required. So this is typically useful when you are dealing with algorithms that are going to rely on certain operators being available. That's a natural candidate for this. That's basically the story of static abstract. What about static virtual? The difference is while the static abstract requires that you implement a method, static virtual allows you to override your own implementation of that method if you really wanted to. That brings us to the last section I want to spend time on. And I saved one of my favorite for the last as well. I have to tell you, I'm a big fan of pattern matching. My first exposure to pattern matching was years ago when I was programming in Erlang. And Erlang has some amazing pattern matching capabilities. Then I saw that available in Scala over the years. You asked me to compare to other languages like Scala. Well, C# kind of caught up to what Scala provides, which is the fun part because you notice languages catching up to each other. Scala was influenced by languages like Erlang and Haskell, and Kotlin was influenced by languages like C# and many other languages. Now, C# is influenced by other languages. So you see this happen where languages influence other languages and they kind of get influenced again. And this is good for us, the programmers, because we get to benefit the power that we have in here. So let's talk about pattern matching as the last stuff that I want to talk about here. We got about 20 minutes, and let's dive in and talk about a few of these features and then see if there's any questions before we wrap this up. So we want to talk about pattern matching. Every one of us, I bet, has written code where we have a series of if else and if else and if else. I'm not a fan at all of a series of if else. Anytime I write those code, I refactor it to use better features as much as the languages allow me to refactor. But pattern matching is a great feature. I like it a lot. Let's just take a quick look at pattern matching before we go into pattern matching with list, which is what is new in C# 11. But let's say process right here. And to process, I send a 1, or to process, I send, let's say, a hello, like so. So I'm going to say a function here, let's say a string process, which takes an object, we'll call it input, like so. And you can say a return, a switch, and input. So a switch can appear in two forms: a switch expression versus a switch statement. So you can use a statement with a case with a colon, or you can use a little arrow for the conditions as well. I'm a big fan of a switch as an expression, especially because that plays a really beautiful role in pattern matching, even though you could use a switch statement for pattern matching as well if you really wanted to. So back here, you can say a return switch input. And if you don't care about what it is, you can simply return whatever, right? I mentioned that the underscore is the international symbol for I don't care. So you could potentially use that in here as well. Let's see, line number 2 is not happy with me. It says expected semicolon, invalid switch, invalid expression term, switch in here. So I want to take this away and use the input like so. So I'm going to simply say input switch, and I want to switch on the whatever and return that value if I can't find anything in here. So it still complains on line number 3. Oh, of course, sorry, that's my fault. I know what it was complaining about a minute ago. So I had a semicolon in there, was not too happy with me. So going back here, I have a switch with an input like so that I want to pass to this right here. And in this case, you can say input switch as an expression, and you can do the matching right there like so. But you can also say, in this case, if it is a string, if you will, as, and you can say got a string, of length, maybe you can specify s dot length over here as well to specify what the length of that particular string is. You could put an expression in there like so. So in this particular case, as you would expect, I would like to put a little dollar in front of it to say evaluate that particular expression. So in this case, of course, line number 3 is not happy with me. I'll fix that. So going back to this code, you can see how you are able to provide that particular feature here and ask it to evaluate that particular property as well. And likewise, you can say maybe an integer I, and you could simply say, oh, something along the lines of got a number, and you could specify what that number is that you really got here as a input. So this gives you an idea how you're able to write these different functions and use a pattern matching syntax. But I want to take this to the next level in here where we can use a array or a list. So let's start with a little example and play with it. So I'm going to go ahead and provide an output, a process, but I will send a list. I will switch over to an array at some point when we need to, because there are some variations that work only on arrays and string, while others work on those and list as well. So let's go ahead and say a new list of string. And what do I want to create right here? Let's create apples. Let's also put oranges here. And then finally, maybe some bananas as well. So I want to process this list as a input as it comes in. So in here, let's go ahead and write a function called process, which takes a list of string. Let's go ahead and say input. And I want to process that here. So return will say input switch, and we will provide, in this case, the syntax to say, if I don't know what it is, I'll return a whatever, right? So that's a good start right now. I'm going to simply return a whatever if I don't understand what it is. But I can do better. You can drop your collection right here like so. So we can simply say, I have an apple with a square bracket, as you can see, and all the way till a banana. And then you can say, got some fruits. So this could be just a first attempt at pattern matching against a list. So got some fruits. If you gave me apples, oranges, and bananas, I'm going to say got some fruits. So that's a very first attempt where you can match a list, or you can match an array as well, which is very compelling and convenient. When I am working with the collection of data, I often want to know and deal with the collection. I do have to say, I am pretty satisfied with the power of this expression here. While it's being type safe, it can also verify what you are receiving as well. Well, in that regard, let's look at the R function, which is pretty amazing as well. So if I go back here, and maybe your collection comes with grapes and oranges and bananas, or you have apples, oranges, and bananas. Maybe that's a kind of data you're going to process. What you can do is you can go to this and say apples are, and you can say grapes like so. And again, you got some fruits in this case, but you are asking it to verify that it's apples or oranges. Without this, you will notice that you have the whatever for the next one, or you have to duplicate it and change it to grapes like so, which is not very elegant. But without having to duplicate, you can simply provide the R right there and make it very concise. So the R is very useful to remove duplication, if you will. So that works really nicely, as you can see in here. You can also do a discard if you wanted to. For example, let's say you have apples and oranges and bananas, or apples and grapes and bananas. So when you run this code, you can see in here on the first one, when you have apples and oranges and bananas, it says got some fruit. But what about the next one? It says whatever. Well, clearly you don't want that. You could have said oranges or grapes, or maybe you just don't care what's in the middle of that. You can put an underscore. Remember the international symbol for I don't care. Hey, you start with apples, you end with banana, you got something in between, I'm good with it. So that's basically a discard you can use as well very nicely. But oh, so those fruits list would fail if the fruit type were out of order. Think you need some intersection union mechanics. Not really. It depends on the use case. If my use case wants a order difference, that's a different case. But a lot of times, again, use this as a trivial example, but typically I've got a message in a certain format, and I want to know if in that format, I want to do some processing. Your goal is not to work with a wild list. If you want to really have any ordering of items, you may have to do contains and so on. This is really, remember, this is not checking for membership. It's pattern matching. We need to remember the word pattern. Pattern matching is you have a certain sequence and you want to match against that sequence. That's the key. This is not a if-else condition of membership. That's why this is based on recognizing a pattern of data. We are not interested in arbitrary sequencing of things. That's not the goal in here. So in this particular example, you say, okay, that's great. Got some fruits, but what's the fruit you got? Well, I know you got apple because that's clearly mentioned. Got some fruits, you can say in here, for example, got some fruits with, and you can say apples and bananas. But what did I get in between apples and bananas? I want to know that, right? So what was that? So this could be the fruit you're interested in. You could say fruit. So you could say in here, a dollar got some fruits with apples and whatever that is, oranges or grapes and the bananas. But how do we know what that fruit is? So here you can say var fruit. So you can specify that you are interested in receiving the fruit. So it says apples, oranges, and bananas, or apples, grapes, and bananas. You can provide the variable name to stand in place. If you wanted to, you can say string. But if you don't care about the type specifically, you can put a var in there as well. And that says you're expecting that particular item to be provided. If you leave out the type, on the other hand, it is going to complain it doesn't know what a fruit is. Maybe a fruit here may be defined as fruit is equal to, oranges, like so. And if you run the code right here, what does it tell you? Well, a constant value is expected, and it tells you you don't want to put variables in there. So your goal here is to say that you're defining a variable that should be used downstream in that path alone. That's what you're providing right there. So you can use a var or a type and then a variable name. But I want to spend the next several minutes on this one feature, which is the ability to slice, which to me is simply absolutely amazing. So what does slice really provide for us? To understand what slice provide, let's go to a slightly more complicated example. Not to the extent where we don't care about the series or the ordering rather, but you really are saying you might have a series of data with a per pattern still that you want to be able to handle. So what you're going to do here is you have apples. We'll start with apples right now. So let's close it right after apples. So I got apples like so, but I could also have apples followed by, oh, let's say I have in this case oranges. But you can also have a situation where you have apples, oranges potentially, but you may also have bananas after this as well. So you could say bananas. So you want to be able to process these three, if you will, and you want to handle it. So how can you deal with that? So obviously in this case, it is going to be whatever for quite a few of those, if you will, which is not going to be what you want. So what you can do here is you can say apples and then simply put a slice, which is a dot dot. So you can say got some fruits. Let's start with that right now. Got some fruits. So you are saying I need to start with apples, but then oops, let's fix that. Line number 8 is not happy with me. So back in the line number 8, obviously I need to close this one, which I'm not doing. Let me close that. So here comes the close of the list. And now, when you look at the output, what are you expecting in here? All right, let me pay attention to this and fix the error right here. So a parenthesis as well that I want to provide right there also. All right, so with this example, you got some fruits in all the three. But what is really the slice dot dot? The slice dot dot gives you everything after. So essentially dot dot is equal to a 0 or more. So it could be empty. That's why apples and nothing after it still matches that, right? So that is a 0 or more. You can put that in the end. That's what you saw right there. But you can also put that in the beginning if you really wanted to. So for example, you can go back here and say that maybe you want to have apples and bananas. So it ends with bananas, bananas. You could have that. Or you could have apples, oranges, maybe grapes, if you will, and maybe bananas. So you want to be able to handle any of these. And maybe you won't start with apples after all. It may be oranges, grapes, and bananas. So what you can do is you can say, I want to have any number of data coming in, followed by ending with bananas, right? So that's what you're saying, that I want to end with bananas. So in this case, you can see, got some fruits on the first one and the last one. But what about this? Obviously, I spelled it wrong. It didn't find it, but let's fix it. Bananas, and that should cover it as well. So again, a 0 or more, but in the beginning rather than the end. You can also have a middle if you want to. So apples, comma, dot, dot. So this says everything in between. So you can see the first and the last meet the criteria, not the first one. So you can put the dot, dot in the beginning, in the end, in the middle, but you can have at most one of those. You are not allowed to put more than one. That's not permissible. So they don't support multiple of those to appear you are required to have, at most one, if you will. That's a requirement. Well, a few different variations from it, which is also pretty amazing. You can capture the slice into a variable if you really wanted to. So going back to this example, we start with apples and bananas, but let's say in this case we have apples, let's say grapes, let's say, and oranges, and of course we have bananas as well. I want to be able to capture what's in between, a 0, 1, or many that may come through. So we could say, got some fruits, we could say with apples, bananas, and whatever it is going to be, you could say curly items. But in this case, I could say string dot join with a comma that I want to join it. And in this case, I want to join it with the items that are available like so. So this gives an opportunity for us to combine things with those values. But what are items, right? We don't have items. It says name items does not exist in this context, and it's complaining it doesn't have a clue what those items really are. So we want to provide a variable like so. So what do? You simply say a dot dot, a var, or a string square bracket, depending on what you want to do. So a var items. So you can specify a variable name to be binding to this. Aha, this is where we got a slight problem. The reason is this only works as much as the slice worked with list as well. This works only with arrays, unfortunately. So I'm going to change this to an array like so. So we have an input coming in, and back in here, I'm going to simply create array of data. So let's go ahead and change this to, let's go back and say, hey, I want this to be a square bracket of array. So we'll turn that into an array, as you can see here. And then we have the collections of the data that are coming in. So we can use a slice on a string, an array, or a list as well, whichever we please to use it on. So going back to this, you can see got some fruits with apples, bananas, and sorry, there's nothing, or oranges, or grapes and oranges as well. So you can take that and store that into a variable. So dot dot var and then the variable name. But it gets a little tricky. The next two will show a little bit more power here. You can also check for some properties if you really wanted to. Like what? Maybe I want to process them depending on the length of the collection that you are dealing with. So in this case, what I want to do is to provide these items. That works great, but I'm going to duplicate that. And here I say that dot dot, and I'm going to say remove the var and say curly and length colon 1 like so. So this is a very powerful way to say you're grabbing a collection of data using slice, but I want to take this path only when the length of that collection is really 1. So got some fruits with apples, bananas, and we can say one more fruit. So I just one more fruit, right, that I have. I could handle that. And similarly, oh, let's see what it's complaining about. So it's saying characters must be escaped and blah, blah, blah. That's on line number 3. Let's go back to this. So we have a length of 1 and a bananas and got some fruits with apples, bananas, and a fruit, an extra curly brace I didn't intend for. Okay, so run it. And of course, you can also duplicate that again and say, hey, this is going to be a length 0 and got some fruits with apples and bananas, and you can stop right there without that silly and that was there before. You can handle that very nicely as well. But you say, this is nice. However, what if I want to deal with length or a property, but I also want to bring a variable as well? How in the world can I actually do that? And that's a reasonable question to ask, right? So I want to mix the property with variable names. So when you look at it here, we have a slice with the property of length 0 and a slice with the property of length 1. But I want to know the name of that fruit that came through. So I want to say apples, bananas, and what? That one fruit that I have, in this case, oranges. How do I bring that in here? So the answer to that question is you go into the slice in here and you simply, first of all, say string square bracket, and you provide a name after the property as items like so. It's still an array, right? So you run that code. Now you can see the compiler is happy. Now you can come to the end of this and say, hey, I have the items. So back here, I can say string.join. In this case, well, actually, it's just one item, right? So items 0 is what I'm really interested in, and bring that in here, and it's oranges. So you can combine it. You cannot use var, but you can use the actual type in here. And the key is you put the type, you put the variable name after the property check. So that works effectively to merge them in together as well. So to summarize what we talked about a number of features right in here. We started with raw strings and looked at the power of raw strings. We talked about the file local type, not something I'm too excited about, but it's nice to have that. We talked about the auto default structs. We talked about required members as well, which is a nice way to eliminate some code duplication. And we talked about Nameof, that can be like a symbol in Ruby and other languages. Static and abstract, what in the world does it mean? We talked about that as well. And then, of course, power of pattern matching with the slice and variable names and properties as well in full glory. If you're interested in downloading the code examples, you can download them from my website. That's given here in this case, and you can download the code examples and play with it as well. One question seems to be an overlap between pattern matching being discussed and link, which is well established, loved. I'm not a fan of lots of ways to skin a cat. Well, I actually would say I am actually a fan of multiple ways of doing, because the context matters. And depending on which context you are using it in, it begins to take a different purpose. A link is very useful in its own regard to express a stream of processing. But there are times when I don't want to process a stream of data. I just want to do pattern matching. Then pattern matching is useful. So context really matters. My recommendation is don't worry about it. Pick one you like. And if there are times when that doesn't meet your needs, then consider the other way and see if that makes sense in a different context. That's a better way to appreciate what we are using. So if you don't find a need for something, don't force yourselves. That's maybe not for you. In that particular context, maybe you'll benefit from it in a different context, and you can use that. So that's all I have. I hope that was useful. I really appreciate you taking the time to join. Thank you so much for the questions and the comments along the way as well. I'll hand it back to Carter. That's all I have. Thank you.